Okay. Hi, good morning, everyone. Just want to welcome everyone to the Fit 5136 Software Engineering again. Today we have Michael Fu. He is one of my PhD students, and he is one of the top who is an expert in the area of AI and software security. So today he will give a lecture around how can we apply AI in software engineering, how can we use AI to improve developers' productivity, software quality, and everything. Okay, so yeah, over to you now. Yeah, Michael, yeah, please share your screen. Yeah.
Okay, let me first share my screen. Oh, good. Start from the first slide. All right, hello everyone. I'm Michael, and thanks, Cla, for the great opportunity. I'm happy to be here to share with you about AI and DevOps. So today we'll talk about unveiling the AI revolution in DevOps, the research and industry perspectives. You may find that the title is slightly different from what we advertised in the email, right? Because in the email, it was AI for software engineering, but I kind of changed it to AI for DevOps. That way it would be more organized, but the content would be similar, right? So before we start today's session, I would like to first introduce myself a bit. I'm Michael, and I'm a final year PhD student in Department of Software Systems and Cybersecurity. My research interest is around software engineering, software security, and deep learning. So my supervisors are Cla and Dr. Tron from a deep learning unit. So this is today's brief structure of today's lecture. So I'll start with the motivation of why I chose to give you this topic today. And what is artificial intelligence? What is machine learning and what is deep learning and large language models happening? And I'll introduce the DevOps paradigm before we can jump into AI for DevOps, right? And I'll talk about automation and security that AI brings into software engineering. And then I'll close with some conclusion and takeaway message. Right, so the motivation, I put a simple sentence here. AI is powerful, and it's important to know it's good and bad. Obviously, so in this talk, I'll focus on the good part of AI. So what AI can bring the automation and security into software engineering. That's a good part of AI, and that's a focus of today's lecture. But there's still some bad part of AI. For example, the ethical issue, energy consumption brought by AI, but that's not going to be today's focus, right? So as a motivation, I would like to first introduce you an interesting guy who is Richard Feynman, and he's an American theoretical physicist. So he had this lecture where he introduced a topic of can machine think? So he's one of the pioneer of machine intelligence, and he talked about how machine thinks. So here, during that time, he used a really interesting example, and I would like to try this example with you guys. So I will read a sequence of number, and what you're gonna do is you're gonna memorize these numbers. And after I read every number, you're gonna start typing in the chat reversely. So you're gonna start with the last number till the first number. All right, are you ready? Okay, let's get started. So 1, 7, 3, 9, 2, 6, 5, 8, 3, 1, 7, 2, 6, 3. Okay, that's the whole sequence of number. And I think most of you would find it really difficult to memorize even in order. And it would be really more difficult when we want to memorize it reversely, right? So here's the whole number, the whole sequence. But imagine that we input this number to a machine. We can actually input like thousands of number into machine and ask it to reverse the sequence of number in less than a second. So that's how machine thinks. And that's kind of an advantage of machine intelligence, right? But that's not what human good at. And during that time in 1985, during Feynman's lecture, he pointed out that machines struggle to recognize faces and patterns. So for example, we have a person called Jack, and we want to input the Jack's image into computer and make it recognize Jack. So during like 40 years ago, it was a really challenging task for computer, because when the computer want to recognize Jack, if the light condition change or the angle change, it just couldn't recognize who is Jack. So it's really hard. It was really hard for a computer to recognize faces and patterns. However, now in 2024, we can actually train deep neural networks to recognize faces at an acceptable accuracy and speed. And we also have Face ID on everybody's iPhone, right? So I would say this is kind of a big jump of AI comparing with what happened 40 years ago. So right now, AI can recognize faces and do much things. So given the advancement of AI, today's goal is I would like to introduce you a broad overview of current AI applications within the DevOps workflow. So what is artificial intelligence? In this talk, I'll focus on traditional machine learning and deep learning. You'll probably ask, what can AI do, right? So let me give you a few examples. It can detect software bugs. For example, we can predict whether a software project is defective or not based on some features collected from the software project. For example, number of developers included in this project, developers' experience in this project, and lines of code in this software project. So based on these collected metrics, our model is going to predict whether this project is potentially defective or not. But imagine that collecting this data is requires much manual effort, right? We need to do feature engineering, then we can train the model. So that there is another thing that's more simple, that we can predict based on the source code. Like we just input the code into the model, and the model would generate a prediction to say, hey, this piece of code is defective or not, if it's defective. So this is what deep learning can do, and it's more advanced because it doesn't require any manual feature engineering in this way. And the other example is that we can estimate story point in agile software development lifecycle. So we can give some features like the dependency, how much time are we gonna spend, and how much effort are we gonna spend, and then the model will predict the story point for us. So this, with this kind of estimation, we wish to use AI to automate the software planning workflow. Right, and there is Autopilot software system, right? Everybody knows there are two big companies that are doing Autopilot at the moment. One is Tesla, another is NVIDIA. So in a Tesla car, we know there are multiple cameras placed around the car, right? So what's happening there is that they use the camera to collect the user driving data, and then use those data to train a deep neural networks using the camera data. And then the model just generate a prediction as an autopilot system. So there are actually more and more software companies that are using AI. So here I give some examples from American companies. So the reason why I use America as example is that America is kind of the biggest country in terms of software, right? So what does software company do? They actually provide service to their customer, right? So what's the role of AI here? AI is kind of helping them to optimize the service they provided to their customer. So for example, in Netflix, what service do we want to optimize? We want to optimize the, because Netflix is a movie watching platform, right? So we're gonna use machine learning to learn how people watch, what people watch during the weekend, and we can build a personalized watch list for the people. So that way we can optimize our movie service to the customer. And for Airbnb, it's the same thing as Netflix, but they are not optimizing the movie. They are optimizing where you live during the holiday, right? And for Uber, it's like we optimize the route from destination to destination, so the driver can drive their passenger smoothly to their destination. All right, so let me talk something about machine learning. So we have some few basic machine learning algorithms. The first one would be linear regression. And I won't talk too much technical detail about the mathematics behind. I just want to introduce an overview image of what does traditional machine learning look like. So in this figure, we have blue dots, right? The blue scatter plot. So those are our input data. So from these input data, what do we want to learn? We actually want to learn the red line, right? That's the linear regression function. So what would be the use case for this kind of function? We can do the price estimation based on some features. So if we want to sell products, we can collect some features from the product, and then we estimate the price. And we also can do the sport analysis using this kind of linear function. So imagine you are a baseball, basketball, or even football manager, and you want to come up with a strategy that you want to win more game during the season. So what you're going to do is you're going to collect some features from your player, from your games, and then find out some correlation between those features and whether you win the game or not. So that way you can optimize your strategy to win more games. The other example is decision tree. We can see it's like a tree structure. And in this example, the question we ask the model is whether this person is fit or unfit. And the first feature that we go into is the age. So we ask whether the age of this person is younger than 30 or not. If yes, then we further ask if this person eat pizza. If yes, then okay, it's an unfit person. If no, okay, it's a fit person. So it's really just a simple example for a demonstration, but this is how decision tree looks like. It just kind of layer by layer and made the final decision. The other important algorithms for machine learning is clustering. So clustering is that we want to find, sorry, give me 1 second. All right. So clustering is that we want to find the cluster in the data. So most of the recommendation system use this kind of algorithm, and we can also do pattern mining and data mining. So why pattern mining or data mining matters during machine learning? Like before you train your model, you want to make sure you know how your data look like, because the data quality would directly affect the quality of your model. So sometimes it would be great to have some cluster in the data. Sometimes it would be really bad to have some clustering because that might introduce the bias that you don't want. So it depending on your situation. And that's why we should probably use clustering to mine the data to see how your data look like before training your machine learning model. And there are more advanced ML algorithms such as random forest, which is an advanced version of decision tree, and support vector machine, XGBoost, etc. So if you are interested in, you can check out this scikit-learn library I put here. So it's a really great foundational machine learning library where you will get everything you need for learning a basic machine learning. And at Monash, we also have 5201 machine learning unit. I took it like 3 years ago during my master study. It was a really great one. So I learned the mathematics behind machine learning, and I got to understand how machine learning works in technical details. Yep, so let's talk about deep learning. So what is deep learning, you might ask? It's actually like we put data into neural networks and the networks generate predictions. So that's how simple it is, right? It's just that simple. But when we look into the data here, we actually find that, oh, we can actually input text, audio, image, and video into neural networks. So this is how this is what makes neural networks so unique, so powerful, because we can actually input different kinds of data into the neural networks, so we can achieve like a bunch of different stuff, right? Let me give you an example. So if I want to input an article, textual article, into neural networks and make it summarize for me, we can actually just put the text into networks, because essentially neural networks are mathematic. They are matrix There are many numeric parameters inside the networks. So it's not gonna work with your text, right? So what we do before we input to the neural networks is we kind of transform this article to a vector, to a matrix, so that we can input these vectors into neural networks, and then the networks will do the linear transformation, nonlinear transformation, and then generate the prediction. It's actually a very complex black box process, what neural networks do in the middle. And it's also one of the research field to explain why the neural networks generate such a prediction. But I would say it's a really complex and challenging work. And the architecture we have for neural networks, we have multi-layer perceptron, recurrent neural net, convolutional neural net, and graph neural net. So in most cases, the recurrent neural net are for text data. The convolution and graph are for graph data like image and video. And I would say that there is one turning point for the development of deep learning. It is the introduction of transformer architecture back in 2017. So it was nearly 7 years ago. So this advanced architecture, it actually solves many challenges introduced by recurrent neural net, and it can actually learn from like terabytes of data. So that's why it leads to the development of large language model and generative AI. So before the transformer architecture, we couldn't feed this large amount of data to train the model. But with the transformer architecture plus the self-attention mechanism in the architecture, we can actually learn from a huge amount of data and build like generative AI and language model. So if you are interested in this work, you can check out this link. This is the technical detail of what transformer architecture looks like. Now I'll talk about large language model and generative AI. There are actually 3 architectures. So you just need to remember that there are encoders and decoders in the transformer, so that we have encoder only, decoder only, and the encoder plus decoder architecture as the 3 variants. And generally, all generative AI are decoder only architecture. So like I said, the advantage of transformer is that they can be trained with large amount of data. So the magic is like we feed terabytes of data plus neural networks, and then we get the AI. So that's how simple it is. And we can see the model size grown exponentially. It was crazy because in 2021, we actually have Switch Transformer, which has 1.6 trillion parameters. It's really big, and it would cost a lot of money to train such model. And this data is only until 2021. It would be even crazy if we look at the data in 2024, right? And here is a brief history of large language model and generative AI. So I would like to introduce you 2 kinds of language model. The first one is like the general natural language one. So these are for general tasks. So the reason is that these models that we see here, the BERT, Roberta, T5, GPT, this kind of model, they are actually trained with general text data, for example, dictionary, online news, or some online article. So that the test, you might want to ask this kind of model to maybe summarize your article and do grammar correction. But if you ask these general model to achieve some source code related task, like, hey, I want to find out whether this piece of source code has any vulnerability or security issue, it's not going to work that way, because essentially how the model performs depending on what kind of data you fit into the model. So if you want to ask some software engineering or source code related task, you want this model that pre-trained on code tasks. So generally how these models were trained is that we feed the data parts from open source project, from maybe from GitHub, and then most of the time it would include like multiple programming language like Java, JavaScript, any kind, C, C++, any kind of programming language. So the model's ability can generalize to many different programming language. So you can ask this model maybe to summarize your code, to generate some code based on your text input, something like that. Yeah, so before we jump into the next step, I would like to introduce some good learning resource about deep learning. So we have PyTorch, TensorFlow, and Hugging Face here. So if you are a beginner, I recommend you to start with Hugging Face because it's a high-level library that uses PyTorch and TensorFlow as backend. And it's really user-friendly. Like you can train your model at just a few lines of code. And Hugging Face is actually, there are many open source language model that you can use, you can download from their platform. And if you are really interested in deep learning and want to learn something technical, yeah, you can then jump into PyTorch and TensorFlow. That's what I used during my PhD study. And there's also one free lecture I would like to introduce you. It's from Stanford University. It's CS231N, computer vision. So I took this like 2 years ago. So during that time, I was like very rookie in deep learning, and I checked out this lecture. There are like, as I remember, 14 different lectures. It starts from some basic introduction of deep learning to tell you what is networks, what is neuron, and then it introduced the convolutional neural networks for computer vision. It also introduced some text data neural networks, such as recurrent neural net, and it closes with some advanced topic about reinforcement learning. So I really recommend this free lecture. And at Monash, there's actually one deep learning unit as well, 5215. It's actually led by one of my supervisors, Dr. Tron. So he is really passionate in deep learning, and I would say his lecture is pretty heavy, a lot of content, but I actually learned a lot from him. So it actually introduced every aspects of foundational deep learning, and you're gonna learn the mathematics behind deep learning. It was a really great journey for me. So before we talk about DevOps paradigm, do we have any question about machine learning, deep learning, AI, large language model? I'll just wait for a few seconds. If no, then I'll, yeah, keep talking. Okay, looks like nothing happened in the chat. I suppose we're on the right track. So you shouldn't have too much technical question, right? Because I'm trying to be non-technical and trying to deliver a lightweight lecture here. So the next step, I'll introduce the DevOps paradigm before we can discuss the AI for DevOps, right? We need to understand what is DevOps. It's actually development and operations, but why we put these two words together? What's this paradigm about? So first of all, I want to first introduce the operations, because you guys know the development, right? Development is like you plan how to build your software, and then you implement your software, and then trying to do some tests and deliver. So what happened after you deploy your software? It's actually the operation team's gonna take the responsibility to running these software system that you implemented from the development team, right? So operations staff take care of system running in large enterprise. They deal with planned events like deploying, upgrading, decommissioning component of the system. They also perform the maintenance on hardware and software system. They also deal with some unforeseen events, like responding to errors caused by bugs, responding to natural disaster, or proactively combining logs and conduct checks to ensure that everything is working. So this is actually, I heard a really interesting story about this unforeseen events from a software engineer YouTuber from United States. So in his video, it's just like it was during his bedtime. like 2 a.m. or something. So he was sleeping. And suddenly he just got called from his manager, his boss, saying like 10 times. So he woke up and his manager just said, "Oh yeah, there's something bad happened in our software system, and you're gonna fix it for our client right now in 1 hour." So he just has to get up and join the meeting and trying to fix the unforeseen events. So this is actually happening in like software engineering industry, and it's really interesting. And we can imagine this is why like software engineer earns a lot of money in US, because they kind of work 24 hours a day. They need to be prepared. Yeah. And the operation team need to employ IT professional with a wide range of skills. It's like, because there is too much stuff that you want to take care of. You want to maintain the code, you want to read others' code, and you want to deploy, upgrade the systems. So you're gonna hire people with a wide range of skills so it can work. And operation and support staff, they actually see the system in a way that nobody else does. So what does this mean? They don't know the architecture of each individual component, but they understand how these components work together. And they consider every software component in the system, plus they need to glue them together. And they are the first to interact with user feedback. Like when users are using the software system, they have something to tell you. The first one to react is the operation team. And they are often first to detect the error. So they have the best knowledge about the error within the system right now and before. So why operation and maintenance are hard? It's like because enterprise systems tend to evolve toward complexity over time. Like the software system you have, it's gonna be more complex every day. Yeah, and it's almost always very hard and time consuming. Imagine that you need to read others' code, right? Because you might have slightly different logic, and it could take you an hour or two to understand, oh, what this guy are doing here. What is this code trying, especially when the code is not properly documented, right? It's a really big headache. And this is especially true if the original developers, they deploy the software and you are running it. But the original implementation team, they are not in the company anymore. They actually jump to other company. And this is actually what is happening in the United States. So the story is that the culture of US software engineer is that they tend to jump from company to companies, because when you hire by a new company, most of the time the salary is higher. So they tend to complete 1 or 2 projects in this company and they jump to other company for their like long-term career. And it might not be the same for Australia, because in US, there are just too many software engineering company. But in the software market share in Australia is just not that big. So companies often handle changing business. For example, now we have a new business requirement from our client. We want to add new functions into our software. So what we're going to do is we're going to integrate this new function. And most of the time, when we want to change something or integrate something into our system, something bad will happen and we need to fix that error. So that's why the maintenance is hard. And in the past, excuse me, we have development and operation separately, so that they are two independent silos. So the development team deploy the software and then they're gone, and then it's operation team's responsibility to operate the software. This is no good, because operation team's gonna spend a lot of time understanding what's the implementation behind development and anything. So the reason that we talk about DevOps is we want to kind of combine development and operation into one and make the communication better. We want to bridge the implementation and operation. So here are some DevOps principles. We bring devs and ops closer from the start of the project, and we follow agile mindset also in deployment phase, and we turn deployment into non-event. So it's like we don't do deployment just once. It's like we want to build our software incrementally every day. So we kind of deploy the software every day, and we build a little bit about it every day, and we have this small cycle, like repetitive development cycle from planning to implementation to deployment happening every day. So deploy is part of the system every day. And this is the main reason why we would like to introduce AI and why we would like to automate the deployment process, because we don't just do it once. When we have repetitive process like this incrementally, it's sometimes good to introduce AI that can automate some repetitive job for us. Remember that DevOps won't completely solve the challenges I mentioned, but at least it can mitigate them. So right now I'll introduce the 5 steps of what's included in the DevOps. The first step is planning. So in the planning step, we kind of gather the requirements from our client and plan what kind of features we want in the software, and then we do the task assignment. Next step is the development. We do coding, implementation, and then we commit the code to the system. But before we can like merge our code to the main branch, we need some code review and some feedback from reviewer so that we can make sure that the code that we're gonna commit is safe and secure before we commit. And then there is a building, testing, and deployment happening. So in this step, we kind of transform the code to executables, and then we test the app, and then we deploy to the server. After that, it's operation and monitoring. So we monitor, what we want to monitor is the app performance and the user feedback. And we kind of have this continuous feedback loop to the planning. So if there is some error during app operation, there is some anomaly detected or a performance issue detected during operation, we just need to report back to development team, and then we need to make quick response to solve the issue. So that's how DevOps work. And any question about the DevOps process? Okay, all good. All right, so then we'll talk about AI for DevOps, automation and security. So this is today's core topic. So why do we want to integrate AI into DevOps? That's the first question we need to ask. The first one is automation. Like I mentioned, there is we want to make software development incrementally, right? There is a repeat cycle happening every day. So we kind of do the same stuff for different kind of issues every day. So we have planning, we have coding, implementation, we need to deploy every day. So if we can kind of using AI to automate this kind of process, it would reduce human workload for this repetitive task. For example, in code review, it really requires maybe 3 or 5 reviewers, you can imagine, to read a piece of code to make sure that it's safe and secure. However, imagine that we introduce another AI model to intervene this process. So we have this AI model to review this code and generate some summary of what's going on of this code. And then maybe we just need one reviewer to review the code plus the suggestion from AI. This way we can reduce the labors that required of code review process. So AI can actually help automate the workflow and reduce some of the manual effort, right? And the other consideration is the security. There are always bugs and vulnerabilities, they are prevalent in the source code. And what AI is good at is that it can learn patterns from historic data and help detect these insecure code. So security, it really matters. Like in Australia, security threats are on the rise. And Australian Cybersecurity Center reported last year there was a 13% year-to-year rise about number of cybercrime reports, 14% year-to-year rise about average cost per cybercrime report, and 25% rise about publicly reported software vulnerabilities. So this is kind of really serious, and we know the technology giants and the government, they are taking actions. For example, Microsoft, they invest 5 billion in Australia for cybersecurity, and Google invests in 1 billion in Australia as well to solve the cybersecurity challenge. And our government also proposes a 2023 to 2030 overview of Australian cybersecurity strategy. So probably you know the classic cases are Medicare 1 or 2 years ago, and another really serious one is the Optus one, right? There are many data breaches happening out there. So the security really is we need to take it seriously. So let's start from AI for the planning step. The first tool I want to introduce is a kind of automation. So this is Trello board. I'm not sure if you're familiar with this product. So it's a software project management tool. It can actually, during the planning step, you actually collaborate with your colleagues on this board to say, okay, this is the task that we're gonna do today, tomorrow. So there's a lot of software planning out there. And recently, Atlassian integrated AI into Trello. So what AI does in Trello is they generate, summarize, and improve the grammar of users' content. So it kind of automate the user's interaction with Trello. And then it also helps the user to brainstorm some new content based on the topics provided by the user. And it can also find and insert action items onto the user's card based on the content. So let's check out this demo video together. 1 second.
Trello AI is available to premium and enterprise users to change the way you work and collaborate in Trello. With the introduction of AI to Trello, you can boost your individual productivity and accomplish even more as a team. Summarize longer card descriptions for a high-level look at the most important information. Or identify action items within a message to quickly and easily craft a to-do list. You can also use Trello AI to adjust your own messages by fixing errors or changing the tone. The brainstorming feature can even help you kick off your next project or craft your next big idea. AI can be used to transform teamwork across all of your favorite Atlassian tools. In addition to Trello AI, Butler Automation is still available for all users to level up their productivity. Simply click on the Automation button to access this feature. Join the future of work and upgrade to Premium or Enterprise today. Learn more at Atlassian.com/AI.
Okay. Okay, so we saw the AI inside the Trello board. It actually helped it like summarize the content to make it shorter and easier to read because it corrects the spelling and grammar. I feel like this is important, especially in Australia, because in Australia we have people coming from different countries. But during the software development, we all use English in different ways, right? So AI kind of integrate everyone's English and change it to a understandable version and make everyone's communication better inside the Trello board. So that's how AI helped. And the next product is Jira. So it's a software project issue tracking systems. It's also introduced by Atlassian. So this issue tracking system, there are actually many issues inside the systems, and developers gonna check which issues are they gonna working on today in the system. So the AI in the Jira issue tracking system helps to automate the issue search, explain the technical term, and answer question promptly. So explain the technical term is like when you're reading someone else's issue, sometimes they'll use some technical word that you don't understand, and it really struggle you during your planning and development. So let's check out the example video here. Okay, all right. So this is how it works. We see that it, yeah, kind of the AI is like Atlassian, they add an AI companion inside their Jira software system, and you can just chat with them. So it's like a chat GPT inside their product. And this makes your life, makes your work more automated, because when you have any question, you can first ask the AI companion instead of open your browser, search from Google, and you need to filter the search results. So it kind of accelerates what you're doing during planning. Okay, so the next one I want to introduce is AI in planning step. It's a research. So it's our research about, it's GPT to SP. It's an explainable story point estimation. So why do we want to do story point estimation? It's really a manual process before. It's like we gather the issue title, issue description, and based on the title and description, we're gonna justify how much story point that this issue report deserves. And the usage of story point is that we can prioritize the task. We might need to do some tasks with higher story point first, then lower story point. So it's really important for like prioritization in agile software engineering. So in this tool, we first kind of fine-tune the GPT-2 model, which is an ancestor of ChatGPT and consists of much less parameters, by the way. And we estimate a story point based on issue title and description, and then we explain the prediction based on historical training data. So let's take a look at the demo together. I'll demonstrate right here. So we have, we first select the project, and then we enter the task title, and then we just click the predict story point. Okay, it says model loaded successfully, and it suggests 5 points. And then it also highlights the word importance. So the word importance is that which word does the model think it's important during the inference process of the model? And we have the explanation showing that, okay, there are some training data in our model, and it's also the model also generates the same prediction story point of 5, and they have the same Windows keywords. So this kind of explanation, I would say it's really important for a deep learning or machine learning model, because imagine you are a developer and here's a machine learning or deep learning model saying that, hey, you're the this title, this issue description deserves a story point of 5, but it didn't like tell you any further detail of why the story point of 5 is generated. So we'll kind of suspect the prediction, and you'll think whether this prediction is reliable, can I use it or not? So by providing this kind of explanation, we want the model to be more transparent, and then we kind of want to bridge the trust between the developer users and the AI model. So that's how explanation works. And if you are interested in this paper, you can check out the link over here. Otherwise, I'll go to the next step, the development step, which is really interesting how AI can do in this step. There are a bunch of AI tools, but the most iconic one would be GitHub Copilot one. I think most of you guys know what it is, right? It's an AI-powered pair programmer. And the GitHub team, they found that, okay, we have the Copilot can provide code completion feature, and it's like the developer can code 55% faster than before. And it can also support text to code generation. For example, if you prompt it with create a new button component, it will transform your natural language to source code automatically. It's like a magic, right? And so let me demonstrate something in Copilot. So for the code completion, yep, okay. For example, if I want to define a function add over here, and we have two parameters, A and B, yep. So it gave us a suggestion about return A plus B based on our function name add and our input parameters. So this is just simple demonstration of how the code completion works in Copilot. And as I mentioned, we also have text to code generation. So here I want to give you an interesting example. So this example is from LeetCode. So let's try this out together. So you probably know, so LeetCode is a website that consists of many coding challenge that you might want to prepare if you want a software engineering job. You want to prepare for a code interview, right? So this is where you prepare. And I chose this question because it's a typical one in something called dynamic programming. So let's check this house rubber together. So you are a professional rubber, okay? Planning to rub houses along the street. So there are many houses along the street and you plan to rub them. But each house has a certain amount, and each house has a certain amount of money. For example, the first house maybe have 3,000, the second house has 5,000. However, there is an alarm system. So how does the alarm system works? It will, like, if you rub continuously, if you rub two houses in a row, then the alarm system will be activated. So what you want to avoid is what you want to do right now is you want to rub the most money out from the houses, but not activating the alarm. So you cannot rub two houses in a row. So that's the requirement. So the first example here, we see there is a nums parameters. So we see that the first house has 1 money, and the second house 2, third house 3, and the last house 1. So the best strategy here is to rub the first and the third the houses so that we can get the output of 4. Now let's try this using GitHub Copilot. Let's see whether it can solve the problem for us. So I'll copy the description here and I'll paste it here. So we ask Copilot to complete the following function and solve the problem. So let's send it. All right, so let's accept it. So it has generated something for us, and let's try whether this works or not. I'll just paste it here, and then we trying to submit our code. Okay, wrong answer. So it couldn't generate the correct answer. Whoosh. So it's actually so when I tested yesterday and even this morning, it actually gave me a correct answer, which surprised me. But this time, finally, okay, I actually tested like 5 times before the talk today. And during those 5 tests, they were all correct answer. But this time, the 6th time, it generates something wrong. So what I want to say is sometimes AI can make wrong prediction. Oh. Okay. I'll answer the question in the chat later. So yeah, so sometimes it can give you wrong prediction, but actually, so during my test, when it generates the correct prediction, I actually was quite surprised, because for me, when I first tried this question, it actually took me like an hour or 90 minutes to finally answer this kind of question. And yeah, but I'm a rookie programmer, so why not? And yeah, so this is a good demonstration of how you need to be aware of the answers generated by AI. So you need to check yourself. You need to do some tests before you can use that code, because it can generate some wrong answer, right? And the next I want to demonstrate is the security aspect of Copilot. So I prepared an example from this CWE7A7, which is a buffer overflow related vulnerability. And why this is the most dangerous vulnerability in 2023, it's because it can lead to memory corruption. It's easy to exploit, and it's also commonly exploited and very hard to detect. And if you have it, it would have a wide impact in your system. So what I'm gonna do here is we're gonna ask GitHub Copilot to see whether it can detect the buffer overflow vulnerability inside this code. So the code that we're gonna look into is this memory copy function. So we have destination buffer, source buffer, and we have a function called return chunk size. But in this return chunk size, we didn't actually validate the value returned by this function. So it will lead to the buffer overflow if the chunk size is, like, for example, a negative value or something, and the system could crash. So what we're going to do is we're going to paste this into another C++ file, and we're going to ask Copilot this security question. Okay, so it did some modification. It checked the value of chunk size and then handle the error condition. So it looks quite good. And let's see what it says over here. So the Copilot says, oh, okay, the code is potentially insecure because it doesn't check the validity of the chunk into before using it in the memory function, which can lead to buffer overflow or other memory related vulnerabilities. So it actually did a great job here. It can fix like a simple buffer overflow. So maybe it can help developers like have better security practices during their development. They just need to maybe copy and paste their code and add something for a Copilot to scan some security issue. But this is really a simple example. And for some complex vulnerability, it depends on situation. It might not get correct answer. Okay, so next I want to talk about the research for for development. So it is PyCoder, syntax-aware code completion. It's actually done by Dr. Kla and one of his students, Wanota. It's probably your tutor, right? And so the challenges they found in AI-based code completion we saw is that existing code completion language model, they do not consider syntax information. So we have different syntax in our code, right? We have keywords like if, else, while, for loop. We have operators, plus, minus, equal, and we have variable and data type. The problem here is that when we input this kind of code into code completion model, the current model, like they just treat every syntax us the same stuff, but it's not like natural language, right? We have different operator and data types. So the PyCoder solution is that they kind of tell the model, hey, okay, this part of the code is keyword, this part of code is data type. Okay, this code plus minus equal, these are operators. So by adding this clarification, they hope that they can improve the code completion performance. So they infuse this kind of syntactic information into the model and further improve the performance for code completion. So it can generate like more accurate suggestion to developers. So it's actually an open source tool, and you can download and check out the full paper here. Okay, next I want to talk about the research that using AI in development for security. This is our research about AI-powered security tool. So it's called AI Bug Hunter. So what it does is, here is a C++ function, and we kind of use this tool to detect, okay, line number 9 is vulnerable. And it also shows the severity of how severe is this vulnerable function. So we kind of want this knowledge of what's the severity, because we're going to prioritize the most severe one. We need to solve the most severe one than less severe one, right? And then it also explained to the developer saying, hey, okay, this is this is a buffer overflow related vulnerability. So the developer, they can come up with corresponding strategy to mitigate this kind of buffer overflow stuff. And we also implement a quick fix button, which suggests some repairs to automatically repair this kind of vulnerable line. And it's actually powered by multiple deep learning model. So you can check out the download link here and full paper. So I would like to give you a short demonstration of how AI Bug Hunter work over here. So this is a web demonstration application. So we have prepared many testing data. So these data were not used for training the model. And then we just select an index. And when we click select, it will start scanning the function from index number 6. And then, okay, here's the scanning results. So it detects a CWID of 119, which is another reading buffer overflow problem. And it says that vulnerable line 10, 11, and 14. So see, we have like 30 lines over here. So if the AI model can suggest saying that, like minimizing the scope that developers are gonna, so they're gonna look into the line number 10, 11, and 14 first. It's gonna reduce their effort, like reading the whole program into just 3 lines. And then they're gonna check it out and what kind of vulnerability it is to come up with a repair. So next, I want to talk about the code commit. The first one I want to introduce is Security Copilot. It's actually a security extension inside the Copilot. And right now, it's a beta testing for this tool. It's called Code Scanning Autofix. So the thing that it does is it generates fixed code suggestion with natural language explanation to automate the pull request workflows during commit. So let's check out the example they show in the video together.
Code security scanning tools help us identify vulnerabilities in our code. But to remediate issues, we must triage alerts, review the relevant documentation, and propose a fix, taking up precious development time. That was until Code Scanning Autofix. Autofix improves the experience by using AI to provide a code suggestion and explanation directly in the pull request. The developer remains in control, being able to make edits using GitHub Codespaces or their local machine, accept the original suggestion, or dismiss it entirely. With Autofix, code security alerts transition from being found to being fixed. Code security scanning tools help us.
Okay. All right, so this is a really good example that we can see. So there is a cross-site scripting vulnerability happening there, and the tool just detect this and then trying to suggest a fix. In addition to the fix, it also provide explanation for human to understand whether this fix makes sense or not. So we can see that there is one reviewer that's responsible for making the final decision of whether I accept this kind of automated pull request. So the thing that we want to achieve by AI is not full automation. It's kind of partial automation that we can gather some useful information from AI, and then we review that kind of information. In that way, we can reduce number of reviewers needed during the code review, right? And next, I want to introduce another research that is JIT-bot, which is an explainable just-in-time defect prediction bot. This is one of Dr. Claus' research as well. So what this JIT-bot do essentially is predict defective commits and then explain why the commit is predicted as defective. So it's done by machine learning plus explainable AI. So explainable AI is techniques that used to explain why the machine learning generate such prediction. So let's see the example together. So here's the example of prediction generated by JIT-bot, right? So let's look into it. It provides a summary chart over here. It's quite technical. So let's just look at the Y section over here. So it detects that this commit has a risk of 60% to be a bug introducing commit. The reason is that the low experience of developer and the low experience of recent developer in the subsystem and the high number of deleted lines in this commit. So these three features are why the model thought it could be defective. And then it also provides risk mitigation plans. So the developer can take actions based on this mitigation suggestion by the model. So this way, it kind of automate the whole commit workflow, the bug detection workflow of developers. Okay, next I'll talk about the code, how AI helps code review. So we know that code review is an effective approach because that like whenever we commit the code, we don't want to merge insecure or vulnerable code into your main branch that will make your software system maybe crash, make your software insecure, so that we need so code review is kind of like quality assurance best approach for during code commit. However, it's a labor-intensive procedure. Like I mentioned, we may need many code reviewers to manually review the code and providing written feedback. So the tool, the security copilot I just mentioned, it can enhance the security and reduce the workflow in the labor within the code review. And for the research community, they are also looking to something like AI-based code reviewer recommendation. So it's kind of based on the reviewer's expertise and based on the reviewers reviewing history, because it's maybe some reviewers are good at language, for example, Python, Java, and other reviewers is good at like C or C++. And if you allocate a like C++ expert to review a Python code, this might not work really well, right? Like the reviewer may spend much time but review less code. So this code reviewer recommendation is kind of, we're trying to find optimized reviewer allocation for different projects so that we can get the most efficient reviewing process. And there's also code review comments recommendation. It's like when developers are writing comments for a code review, the model will learn how you wrote before and learn your current project and recommend some comments to automate your like reviewing experience. And next, I will talk about building, testing, and deployment. So I would like to first introduce Ansible. So it's an automated configuration management tool. And Ansible is an open source IT automation engine that automates provisioning and essentially configuration management, application deployment. So the most important part of Ansible, I would like to say, it's infrastructure as code. So what's infrastructure as code? It's called YAML playbooks inside Ansible, but essentially it's just a YAML file. So it kind of, because in your system, you're gonna have many configuration, right? And if you can like kind of pack those configuration into a human readable file, so that's what infrastructure as code do. And this playbooks, it defines a series of tasks to be executed on remote hosts, specifying actions such as installing the how do we installing the package, copying files, and how do we configure the services. So its simplicity make it easy to define complex automation workflow. So like I said, the DevOps doesn't work like waterfall software development, right? Because we kind of build software incrementally every day, and we kind of maybe there are many deployments happening every day. So we want to automate this kind of deployment. And the infrastructure as code and the tool like Ansible is just kind of release developers' pressure on like doing so many deployments every day, kind of automate the deployment. And we also have similar tool called Puppet and Chef. You can check out through the links. The other thing I want to introduce is from research. So this one is a test case generation research. And why do we want to test case generation? It's because there is a lot of testing going on every day, right? We need to test the software. And if we can have test case generation model, it's kind of like when I'm writing test cases, the model can suggest me some more test cases that I can review. So the developer can maybe focus on some other aspect. So here is the A3 test approach, assertion, augmented, automated. I guess this is why it's called A3 test, right? Because there are 3A. And so they found the challenge in AI-based test case generation. It's kind of lack of assertion knowledge and lack of naming consistency and test signature verifications. So it's just the current test case generation model. They didn't care about the assertion knowledge, but the assertion knowledge, it's really important when you're writing test case, right? So the solution provided by A3 Test is they first, before they can train the model on test case generation, they first pre-train the model to infuse some assertion knowledge by using the task called assertion generation. So the model will have some knowledge about, oh, okay, I need to take care of assertion during test case generation. Then we train the model for on our test case generation data to let the model perform. And they found that this kind of approach actually like enhance the model awareness about the assertion knowledge when generating the test cases. So they can generate like more useful test cases for developers, because previously, most of the time, the test case generation model just generates something that's not usable for developer, and it's waste of time. So here is a full paper. You can check it out. And finally, I'll talk about operation and monitoring. So I think the most typical one would be this Datadog. So this is a cloud monitoring as a service product. And what it does is it's a real-time app performance monitoring, threat detection, anomaly detection, and integrated dashboard. So it has like a comprehensive overview dashboard to let the user to observe the infrastructure, system logs, and service dependencies. So recap what we've introduced in DevOps paradigm, right? For the operation team, in their mind, they kind of need need to know the dependency of services of your software, right? Because in your software, you're not gonna just have one service. There are gonna be multiple services, and you need to have a mind map about the dependency of those services. So the Datadog product is kind of provides you overview access for you to operate or monitor your software easily. So let's take a look at the demonstration of how it works. Yep. Yep. So this is the how Datadog works. So we see that, excuse me, we see that there is a dashboard for system logs, right? So essentially, system logs are how we monitor the performance of the app. And it also provides threat detection or anomaly detection. So remember, in our operation team, we want to respond to this kind of unforeseen error quickly. So this kind of AI powered operation and monitoring tool is just kind of helping us to respond to those unforeseen events more smoothly, and then help us to observe the overall system architecture during the operation and monitoring step. Okay, so here comes the conclusion of today's talk. So here's the recap of some main points. We've introduced AI application within software engineering, focusing on DevOps, automation, and security. And we highlight the role of AI in DevOps for automation and security. The key takeaway are AI-driven automation in DevOps accelerates the software delivery, because we see that there are a lot of tools that are useful for software planning, software development, deployment, operation, and monitoring. And AI-powered security solution fortify defenses, detect anomaly, and mitigate risk in software development and deployment pipelines. So that's probably all for today. And finally, I want to share some good relevant papers. If you're interested in what's going on in AI and software engineering, even if you're not interested in research, it's also good to know some what's going on about AI in SE, right? So this paper is large language model for software engineering, and it's a systematic literature review. It actually collects hundreds of papers from 2017 to 2023. It kind of summarized the landscape of what's going on about AI for software engineering. So it's going to introduce some iconic AI models, and then what can they achieve in software engineering, and what researchers and industry guys are doing currently. And there are also some future outlook paper that I think you might be interested. So the first one is Rethinking Software Engineering, the Foundational Model Era. And the second one is LLM-based multi-agent systems for software engineering, vision, and the road ahead. So the reason why we have this kind of paper is right now, we have AI models. So the way we are doing software engineering would be totally different comparing with 10 years ago or 20 years ago. Imagine 20 years ago, we don't even have ChatGPT or something, or some large language model is coming from just after 2020, right? So right now with this kind of AI, we need to think about how we can work with AI. So what we want is AI plus human achieve better productivity than just human. if we don't think about how we use AI, it could be we can just throw AI into software engineering and it's not gonna work. So we need to not only build the AI, but we also think about how we can work with AI to achieve better productivity. And yeah, that's all for today. Thanks for your attention. And here, I would like to ask you for a favor. It's an anonymous evaluation. So if you can scan this QR or go to this web address, I really appreciate you give us some feedback about today's lecture and talk, how you feel, any suggestion is fine. And there are just 2 questions, so you might complete it in 5 minutes. Really appreciate that. All right.
Very good. Thank you so much, Michael. Maybe can you please put the link in the Zoom chat as well?
Okay, sure.
Yeah. And maybe you can, take the questions and answer. Yep.
Yep. Yeah. So if you have any question, just feel free to ask. I'll first answer the the question from the chat. The first one is this what's called a hallucination? Sorry, I don't understand that. I don't understand that that term. But the question is probably about the coding challenge we had, right? The dynamic programming. So so what we was doing there is we trying to figure out a strategy to rob the houses and get more money. And the reason why it's dynamic programming, and it looks like a greedy search problem, but it actually is not, because you need to update your strategy throughout your robbing. So that's why it's called. And for this term hallucination, I'm not really sure. Maybe you can ask ChatGPT for and for the second question is, could you please share your thoughts on whether AI might one day completely actually replace software developers? Okay, this is actually a really hot discussion, because I saw there are many videos on YouTube about like AI programmer. So currently, yeah, because we've trained this large model, so AI can actually write some code. But in my opinion, it would be the best case would be human plus AI, and the human should be the one who makes the final decision, like the example we saw with Copilot, Security Copilot, right? So it's the human who finally decide whether I should merge this kind of commit. It's not AI to automate the full workflow. And for if you want to implement something, I would say if you are developing an app and you just want to add a new button to your interface or something, this can completely done by just AI. But there exists some more challenging tasks during software development. So I would say it's quite impossible that AI would replace human for like coding. But maybe, for example, right now we may need like 10,000 of software developers around the world. But with the advancement of AI, this kind of 10,000 could be reduced to maybe 2,000 or 3,000 more advanced software developers. So I would say it would be more competitive for you to get software engineer job in the future if AI got advanced. Wait, okay, so would we be reduced to co-reviewers rather than actual programmers? That we should slow down the speed of research. Okay, this is another interesting question. So for the so about reducing the I would say that before you can be a code reviewer, you need to know how to write a code, right? So it's kind of step by step. and you will do more code review job if AI can actually write a lot of code. But imagine when the AI gave wrong answer and you detect it, you still need to write the replacement code. So the thing is, you still need to follow the same learning curve of how to become a software engineer. You need to first learn how to write basic code, and then you can do code review, trying to understand others' code, understand AI's code. And then if there is something wrong, you still need to replace AI's code. For another question, do you believe that we should slow down the speed of AI research development? I would say this is kind of a difficult one. So these 2 months, there is a really hot discussion in United States. If you follow the news so I saw a news from Wall Street Journal yesterday. So they are talking about the energy consumption. So because every company, like I mentioned, Netflix, Airbnb, Uber, they are using AI, they're developing new AI. So the thing that we're using language model is energy consumption. And the news I saw yesterday, the title was United States has not enough electricity for AI, for their AI development, something like that. So I would say it will slow down itself because it's a supply and demand question. When you don't have enough electricity, the price of electricity will go high, and it will kind of just slow down the development of AI automatically. That's how it works.
Very good.
Thank you.
Any other questions from the student? If there is no more, then yeah, can you please everyone give a round of applause to Michael? Yeah, really thank you so much for your talk today. To be honest, I find it really helpful. I'm not aware of the Atlassian AI, that one before. Yeah, I didn't know that there's a Trello AI and the new version of the Jira.
Yeah, for the Trello AI, they just introduced like 2 weeks ago or something.
I see.
Yeah.
That's why. Yeah, it looks really cool. Yeah, very well done. And hopefully, yeah. So what I mean is that the takeaway message of this lecture is that probably student will be aware of the future of the software engineering, and it's not just about coding at all, but in the future, it's about how can we effectively use the AI software tools to help yourself improving the productivity as well. And yeah, I think that's all. So actually, there is one question about whether the AI will replace human or not. I would say personally, it will not, but nowadays we need to know how to use AI to maximize your productivity as much as possible, and that will be the key advantages for yourself, yeah, when you are on the job market. Okay, all right. Thank you so much, everyone. And importantly, the survey form here. So currently, Michael is on the training for the teaching. So if you have any feedback, could you please provide feedback in the form link as well? And yeah, he will be really appreciated. Yep. Okay, all right. Thank you so much, everyone. Bye-bye.
Thanks, everyone.